Good morning, students. Now I'll explain you 7-segment LED display and output device, how it is being interfaced with the 8085. Now we have a problem statement here. We have to design a 7-segment output port with the device address. It is given that the device address is F5. Now using decoder, NAND gate, NOR gate, or and it is given common anode 7-segment LED. Now second point is given write bar, IO by M bar, and these are the given signals, and you have to generate IO write bar. That means you have to write the signal into the LED display. Now we have to explain the binary code for that and the code which displays 7 at the port. So we want LED display should display 7. Now before going to this interfacing, I would like to explain you the hardware description of 7-segment LED display. Now 7-segment LED display is just like this. You have seen in your labs also. This is 7-segment LED display, this part. Now this we will name each and every bar, each and every LED as an alphabet. Suppose A, B, C, D, E, F, G. So these are the 7 segments, and the 8th one is the decimal point, that is given here, DP. Okay, now we are having two types of LED display. Now we are having common anode and common cathode depending upon the configuration. Now if we see the common anode, the anode part is common and data is being attached to the cathode part, such that 0 means LED will glow. LED will glow. So 0, if the data line is 0, it means LED will glow, because in common anode this part is given at the high voltage side, and this part, if it is given at the high voltage side, then high and high it becomes the LED will not glow. Now LED will only glow when the current pass through it. And how current will pass through it? If this part is high and this part is low. So whenever the data line is 0 in common anode, then only the LED will glow. So if we have to glow 7, that means this 7, which part of the LED should glow? A, B and C. A, B and C should be activated. Now if we are using common anode, that means A, B, C should be 0 and rest should be 1. Now if we see the common cathode part, now in the common cathode part, now if we see common cathode, all the cathode part is being common and anode is being attached to the data lines. Anode is being attached to the data lines, such that whenever we have to give 1 at the data line, then only the LED will glow. So in this, if we have to glow 7 in case of common cathode, what will happen? This A, B and C should be high. These should be high and all other should be low for displaying 7. Similarly for displaying 8, if we have to display 8 for example, then in common anode, all the A to G should be 0. So A to G should be 0 and this would be taken as don't care. Now if this 8 would be displayed in the common cathode, all should be 1 except for decimal point, it should be don't care. Now I hope this would be now clear to you, common anode and common cathode. Now in the question we have been provided that the address is F5, the address of the LED is F5 and we have to display 7. So we have to display 7 for what? We have to display 7 for common anode. Now first of all, what should be in our accumulator that would be transferred to the output device? So we should have the value of the data which will glow the only 7 as our output. Now if we see 7, now for 7 A, B and C should be 0 and rest should be 1. So these are the segments A to G. Just write these segments with a decimal point that is not connected here. Now if we see 7, now A, B, C for common anode I have explained to these should be 0 and rest should be 1, and don't care I have taken don't care as 0. So 7, 8 would be the data that would we have to transfer to the LED to display what? To display 7. Now what is the procedure? We have to move this 78 in the accumulator and we have to out this with the help of out instruction. Out, where we have to out? To the port address of LED. Port address of LED is given to you F5. So if we see the instruction, we have to give the instructions also. Now if you see the instruction, first is you have to move 78 in the accumulator and out to the LED, then halt. Only this is the program that you have to write for the interfacing of LED. Now next, if we have to interface our LED, we have to use the address map. So this is the address map as F5 is given to us. So A7 to A0, we will just write the F5 1111 0101. This is F5. Now if we see this, the last 3 would be taken as the input to the decoder, so it is 101. Now what will be the output for that, which is to be interfaced with the enable? That output is 101 is 5. So O5 would be attached to the LED enable. So we will use these status in this diagram. I have already explained you this part. Now here we have taken the output display. Now if we have taken an output display, we have to take latch. Now for latch, enable is high signal. It is a high signal, so bubbled AND is used here. With the bubbled AND, we will give IO write and O5. I have explained to you, it is O5 as the output. So O5 and IO write is being given here, such that the data lines which are connected to the accumulator are provided to the LED display by latch. Now how it is displayed? Now first D7 is don't care, rest status is known to us. Now it is being connected to the common anode LED display. So we will just draw the common anode LED display with a current limiting resistor with this. Now you don't have to mention these things, 2, 3 pin diagram. Okay, you don't have to mention this. Just write A to G and decimal point. Okay. So this is all about the interfacing of LED display with the 8085. Now if we have to use a hardware circuit with this for the input, now just we are having DIP switches for example. Now in DIP switches we have to use this DIP switches to give the input to the accumulator. Now this is your choice, it is somewhat different as in case of the previous example. You can take the same and you can write down O4. Okay. Now what we want to have, we can just write here 0 or don't care, that we have taken. Next is 7 111 and next is 8 to display 7 at the LED. So 111 means switches are open, 0 means switches are closed. So we will just set the switches like this to display 78. Now first one is don't care, so you have to use either close one or open one, this is your choice. So this is the interfacing of DIP switches for the same example. Now this is the interfacing circuit having the address map. Now next is memory mapped IO. Now next is memory mapped IO. If we talk about memory mapped IO, the input and output devices are assigned and identified instead of 8-bit address. These are being identified by 16-bit address, just like memory. Now instead of we are using in and out instruction, we will use memory read, we will use LDA and STA, just like in memory interfacing. Now instead of IO read and IO write, we will use memory read and memory write here. So if memory mapped IO will come, you have to use whole address map, that is from A0 to A15, and just like memory interfacing, you have to interface your input output devices, but the address is being assigned for the input output peripherals. Now here if we use STA or LDA, now if it comes explain the instruction for memory mapped IO, you have to explain STA and LDA with the timing diagram of the both. Now this is your STA, I have explained this to you earlier. Now it is the similar, in the similar way you have to use only 3 steps, just like IO mapped IO. Here also you have to use 3 steps. You have to decode the address bus to generate the device address pulse, but here the whole address bus is used. Instead of 8-bit address, you have to use 16-bit address. After that you have to combine it with the control signal, but instead of IO read and IO write, you have to use memory read and memory write here, and you have to generate device select pulse, and device select pulse is being given to enable the IO port, and it can be latch for the output device, it can be buffer for the input device. Now here an example is being given to you. This is the example of home automation. Now you can explain this in the application of 8085 also. Now in this example I will explain you, DIP switches are being used. These are the DIP switches, these are being used to give the input, and these are the output devices for the home automation systems, and relays are being used for these output devices, just like cooling system, heating system, fire system, PA system, that is public address system, lights, fire exit gate, okay, and entry gate, exit gate. So all of these are the for the home automation. Now which one is 1? It means it is on. So we want heating system as well as lights should be on. So all should be off, but heating lights and lights should be on. So what will be there? 0 1 0 0 1 0 0 0. This should be our output. Now if this should be our output, that means STA, we have to load this to our output. Now if we have been loaded with the same data, so how we load the same data? We load the same data with the help of DIP switches, but in the inverted manner, because in DIP switches, whichever switch is on, it will provide 0 to us. So if we switch on our second and 1 2 3 4 5 second and fifth one, now just see this switch S6 and S3. Now S6 and S3, just see it. Now if we switch on this, 0 0 will be given to the data. So our data would be 1 0 1 1 0 1 1 1. So this will be our data. Now this data is being complemented and then given to the to the output device, such that our heating and light systems are being on. Now this part of the this part of the interfacing is same, but instead of using only 7 address lines, we have to use whole of the address lines, that is up to A15. Now here O0 and O1 are being provided for the output as well as input respectively. Now if we have to draw the address map, first you have to draw the interfacing, then the address map, and then the instructions, that means the program. Now if you draw this as the interfacing circuit, O naught, if we see O naught, it means A naught, A1, A2, ये तो 0 हो गए, all should be 0. And what about the rest? We have used here NAND gate, so A4, A5, A6 should be 1, A8 to A15 should be 1, but A3 should be 1. So all are 1 except for A2, A1, A0. So similarly O1 for O1 it becomes 0, 0, 1. Okay. So just see the address map here. This is the address map. Now if we see the address map for O0, these are the 0, 1, rest all are 1. So triple F8 would be the address. So this is the address for the output. For the input, triple F9. So what will be the instructions or the program for that? We will load the accumulator with the input. So LDA FFF9. So whatever at the DIP switches, it will be loaded to the accumulator. Next would be complement. What will be in the accumulator? It would be complemented. So 1 becomes 0, 0 becomes 1, and then we will store this content to the output device, STA output FFF8. So whatever will be there will be stored to the FF8. So when data comes to this, whatever will be 1, it will switch on that relay, and whatever will be 0, it will switch off that relay. So accordingly heating system and lights would be on. So you can use any of the example with this. Okay, this is all about memory mapped IO. So IO mapped IO and memory mapped IO, both are clear to you now.